Hi, and welcome to another Hopper Libraries video. Hopper is a development environment on Windows with it's a modern semicolon and curly brace language, similar to Java or C#, but designed to run on small devices like microcontrollers. So this is on an RP2040, like Raspberry Pi Pico type micro device. And this video is about the display library. So this is an ePaper display, but it applies to other displays in the Hopper environment as well. Anyway, you built your project, you got your display in there, but you might not have had a choice in how the orientation of the display was going to end up, which way was going to be up. So how do you flip the display if you finish your project and it's upside down? Now what do you do, right? So let's go and have a look at this display. It's a Think Ink display from Adafruit, and what we're looking at here is some sample code I've written, just with some garbage, some test text in there, lorem ipsum, and I draw the text. So let's have a look line by line how you use the display library. So first you have to choose a machine. You have to choose which microcontroller you're using, and that's because the way these are plugged together in the the feather wing that's plugged into your feather board, the pins aren't the same in different microcontrollers. So you define your microcontroller so that it knows which pins are being used to drive the display. You then need to go to the devices folder and find your actual device, so this actual device uses a display driver, and it's based on this chip, the SSD 1680. Anyway, so you have to choose your actual device. And then if you're going to draw text, you need to choose a font as well. And the font I'm using is Verdana, which is 5x8 cell characters. Okay, so you've done that. Now how do you set it up? Well, it's a one-liner to set your device up. You just call Display.Begin, and if you've configured it correctly, you should get past that. If not, you'll see this message to the serial port in the debugger. Then I just call my sample function, which is DrawText. What I often do is I'll use the built-in LED to tell me where I am. Because these ePaper devices take up to 10 seconds, or sometimes 20 seconds on the bigger ones to actually refresh, it's kind of nice to know when you're done with that, especially if you've got a bigger program around this, to know when you've exited your display update, and that's when I turn it to false again. So LED true, turn it on, LED false, turn it off. Okay, and this IO.Write line can be configured so that when you're running on a microcontroller, by default, the IO library will write to the serial port so that you can see it in the debugger. Kind of like the Arduino serial println or serial print. However, if you switch on Echo to LCD, it should be Echo to Display. I'll actually fix that shortly, so it'll probably say Echo to Display in future. So I switch that on to true. Then whatever I write to write line will go to, and it's going to be this lorem ipsum text here, will go to both the display and the serial port. So I can see it in the debugger, and I can see what's being written to the display. Display on Windows is called screen. And the screen is slightly different to a regular display in that it's you can't draw graphics to it, you can only draw text. There's two colors, foreground and background color. And it has coordinates, unlike a serial port. So if you're writing to a serial port, there's no move my cursor to some position, whereas on a display or screen, you can move to a position on the screen. Okay, foreground color. In the case of these ePapers, displays, the foreground color is actually black and the background color is white, which is the opposite of, say, the screen on Windows. You call screen clear, it'll use these two default colors that you've set. Then we're going to draw our text, which will wrap. And we're first drawing it in black on white, and then we change our foreground color to red, and we've drawn a blank line between them. And then we draw it a second time in red on white. And then when we finish drawing our text, we turn that echo off again. Otherwise, all our diagnostic stuff will keep coming to the serial port. And we've put all these display functions in a sandwich between suspend and resume of display. And what that does is it collects all the changes you're making to the display between suspend, and when you hit resume, if we go and look at what resume does, I'm right-clicking on resume. Every time you go into suspend, it increments this number. Every time you go to resume, it decrements it. When it gets to 0, it updates the display. And other graphics commands are wrapped in the same kind of sandwich. So it's nested. Control backspace to go back to where I was. Anyway, so this is how you suspend changes to the display and then make them all happen in one place, which is kind of what we want when we're updating ePaper, since it takes quite a few seconds to update. All right, let's build that. All the shortcuts are on the menus. This editor is written in Hopper. The whole toolchain is written in Hopper, the preprocessor, compiler, optimizer, code generator, all that. If you look at the bottom of the screen, that's successfully built. And now I can launch the debugger. Control F5. Control F5 is just running at my wrong key. Control C to stop. I want to launch the debugger, which is just F5. Okay, so when the title bar changes to green, I know I've launched into the debugger, even though this editor looks very similar. And we can single step through this. So if I F10, it says at the bottom it's successfully uploaded it to my device. If I F10, that'll start stepping. And I can step over Display.Begin, and it failed. So why did I don't think it did fail. It's because I'm running an optimized version, so the line numbers don't correlate 100% to the to what's happening in the debugger. So if that happens to you and you're trying to debug something when you're in the editor, you'll want to turn off optimization. It's also pretty slow when I'm running in the debugger. So if I Control C here and then just run it outside the debugger, it goes much faster. And now it's updating the display. You see the flashing going on there. And like I said, it's going to take a few seconds. And there's exactly what I was looking for. So you can see that the text is upside down now. The red text is at the top and the black text at the bottom, which is the opposite order in which we drew them. So this display is not in the correct orientation that I want. So how do I fix that? And at the bottom, I can see program exited, session reset, because that's all this program does, is just draws this sample text. So Alt F4 to exit the debugger. I'm going to turn off optimization so I can demonstrate. So on this menu, if I turn off running the optimizer. So the display has some settings here, and some displays, some libraries do the rotation thing, rotate through 360, rotate through 90, rotate through 80, 180, rotate 270. But even if you do that, sometimes you still end up with the screen sort of inverted in a way you don't like. So anyway, so I prefer just do flip X and flip Y, right? So if we flip them both, if we invert the horizontal and the vertical direction, that should that should get our text the right way up. So let's try that. So F7 to build, not running the debugger this time. F5 to launch into the debugger. I am running the debugger. I'm not optimizing the code this time. So it'll be a bigger, slower program. So now if I press F10, it's successfully uploaded. So if I press F10, I should be in the right places. So now I'm flip X, flip Y, and Display.Begin. Yes, it succeeded. And now I'm just going to run it with Control F5 to run it outside the debugger, because it'll be faster. It's still slow because it's not the optimized version, but it's fast enough. And then we go with our screen update. And So we can start to see the bottom start to turn red. And yeah, that red glow, the red glow behind the device goes away when I'm outside, when I've hit this LED false here. So because the red glow was the built-in LED. Okay, so that's the correct way up. But there's one more thing you can do, which is you can change the orientation of the display in terms of portrait or landscape. So what does portrait or landscape truly mean? It only really makes sense if your horizontal and vertical direction are a different number of pixels, which is true. And by default, Hopper assumes that the bigger number is the width. So it assumes that, you know, displays work like computer screens as opposed to like phone screens. And if you say portrait, then it's more like a phone screen, where the bigger dimension will be the height. So I'm going to turn optimization on again and rebuild this. So now we've asked for portrait. So we've asked it to be in the orientation of like a phone screen. So let's try that and see what happens. And you know, there's no point in trying to preconceive like which way up things are going to look in terms of flipping X and Y. Easiest way to figure it out is just to try it. So and see it. And what we can see now, I don't know if you can actually tell that, but we have succeeded in making a like a portrait orientation display. So things a bit fuzzy here. But you can see where it's written lorem, it's written it the wrong way around. So, and the library still thinks of this as the Y direction. That's why it's not like width or height. So, I mean, I could be wrong. I'm just quite dyslexic, so if I get it wrong, it doesn't matter. I'll do it the other way. So if I go and flip the Y direction, hopefully that should fix the problem for us. And let's try that again. You can also see by the justification it's on the wrong side. It should be on the top, you know, like flush on the left. And I got it exactly wrong. So the Y is what we think it is. So, and this kind of experimentation of just try it and get it until it's in the correct orientation, because there's not that many permutations. So now we've got it as if it's a, you know, a phone screen that's this way up, right? And if I do, let's go and do that again. If I swap them both around, like flip that one, don't flip that one, it'll give me a phone screen that's in the other way up. Let's check. Here we go. Wait, see the red glow behind? That means the screen's still updating, and the red glow should go away when it exits my DrawText function. And it looks like it's almost, there we go, the red glow's gone away. All right, so now let's unplug it. The joy of ePaper doesn't require power to keep going. And we can see we've got, let me take these spaces off the back. We can see we've got the other orientation for portrait. Anyway, that's what these settings are all about. So there's only 3 settings really, but they allow you to configure your display either portrait or landscape, and then let you flip it around in any orientation you like. So it doesn't matter how it's configured inside your device. Anyhow, thank you for watching, and I look forward to your feedback.